This is Unit 8, Lesson 5, and as you can see from the title, we are going to be doing some applications of these rational expressions that we've been working on for the last 4 sections. So you're going to see a little bit of everything. You'll see some multiplication, some complex fractions, some adding and subtracting. So it's basically just everything we've seen so far in this unit, just kind of within the context of these geometric formulas. So over on the left-hand side, we've got some sketches for you, some sides that are labeled by these different rational expressions. So we're going to do a few examples on each page. So we're going to start with number 1, and it says find an expression to represent the area of the rectangle. So while you guys are working on these, there's some of them that I would assume that you know the formulas. If not, feel free to look them up. We'll get a lot of them on this page. So number 1, the area of a rectangle. Area is either, base times height or length times width, whichever variables you want to use. Either way, it's going to be this dimension times this dimension gives you the area. So the work is that we are going to take these two sides and multiply them together. So let's call this one the base. Let's call this one the height. We're going to multiply them together, which means we're doing the multiplication, which is like from 8-1, and that is where you factor everything that you possibly can, reduce the monomials, and then eliminate any common binomials. So I'm going to factor them down as I'm writing them over on the right-hand side. So our first numerator is a 2x, and that's just a 2x. It doesn't factor down anymore. This denominator, x squared minus 12x plus 27, that can factor down. So for the x squared, I'm going to start with x times x, and then multiplying to 27, adding to a negative 12 would be minus 9 minus 3. And then multiplied by this right here, the numerator is x squared minus 81. Hopefully we recognize that as the difference of squares. So that would be x minus 9, x plus 9. And then the denominator, 4x cubed plus 36x squared. We can start that one with a GCF. There's a 4 and an x squared that they both have in common. And then if you take that out, this leaves you with an x. This leaves you with a plus 9. So everything is as factored as it possibly can be. When we reduce, first thing we do is we reduce down the monomials. So these are the monomials, 2x over 4x squared. We can cancel out a common 2x. When you cancel 2x here, there is still a 2x left. And then after you reduce the monomials, we can eliminate any common binomials. So common binomials, remember you can think of this as like one big fraction. We have an x minus 9, x minus 9. We have an x plus 9, x plus 9, and that is it. So there is nothing left behind in the numerator, so we just write a 1. In the denominator, there's an x minus 3 times 2x, so I can distribute that 2x, and so my denominator looks like this. And that would be your final answer for number 1. All right, so you see what we're doing is essentially just what we've been doing in this unit, just like I said, within the context of geometric formulas. The next one we are going to look at is number 3. Number 3 says the area of a rectangular garden is given by this expression here. The length is this expression here. Find an expression to represent the width of the garden. So we have area is length times width, or base times height. Up here I wrote base times height. Here they specifically mentioned length and width, so I'm going to do that. It says find an expression to represent the width. So we want to solve for W. If we're trying to solve for W, we want to divide both sides by L. So divide the left-hand side by L, and when you divide the right-hand side by L, it's just W. So that's the formula that we're going to be using, and we can write that over here. So the width of the garden is the area, which is this expression right here, a squared over b minus b, and then divide that by the length, which is this expression right here. So a over b plus 1. So this is now in the category of complex fractions. It's a fraction of fractions, and we had a step-by-step process for that in section 8.3. What we do is we need to make sure that the top and bottom each just have one fraction. So to combine these up, this has a denominator of b, this has nothing. So you can think of that as like b over 1, and we're going to multiply by b over b so that I can get a common denominator of b. So I have a squared minus b times b would be b squared, and then over our new common denominator of b. Divide that by all this, and we do the exact same thing. This is just a 1. This has a denominator of b, so this one we also want to multiply by b over b. So now we have a plus b over a common denominator of b. So now I wrote it so that I have just one fraction in the numerator, just one fraction in the denominator, and then I turn it into a multiplication problem. So dividing is the same as multiplying by the reciprocal. So I have this part, a squared minus b squared, which I can factor down as the difference of squares, a plus b, a minus b, divided by b, and I'm turning this into multiplication by the reciprocal. So times, and then I flip this and I write b over a plus b. So this is just like one term right here. So now this becomes kind of like number one. I start by reducing any monomials. B and B are monomials, and they actually end up canceling. Then I can eliminate any common binomials. So I have a plus b, and all I have left is an a minus b. Okay, next, and then our last one for this page, we're going to do number 5. It says find an expression to represent the volume of the rectangular prism that is shown below. So volume of rectangular prism is length times width times heights. Let's call this one the height, and then we can say this is the length and this is the width. So this is pretty similar to number 1. It's just a different geometric formula, and it's adding one more extra layer, one more dimension to multiply in and factor down. So length, I'm gonna write this one, so 18x squared, that's just a monomial, so it doesn't factor, over 45x squared minus 18x. This one I'm gonna start with a GCF. They are both multiples of 9, and I can take out an x. And without the 9x, this one would be a 5x, and this one would be a negative 2. So you've got that, that's the length. Times the width, we take this one, factor it down. So the top part, x squared, I can factor down x times x. It's supposed to multiply to 48 and add to 14, and that would be 6 8/8. Denominator, I have a 36 minus x squared. It's a difference of squares. It's just the kind of opposite order of the way we're used to seeing it. So it's 6 plus x, 6 minus x. And yes, it does have to be in that order because here the 36 is first, so here the 6's have to be first. Times, and then this right here. This numerator, I'm going to do a little side work because this 5 does not divide out, which means I have to do slide and divide. So a little side work for that. Take the 5, multiply it by the 12 at the end. And that's x squared minus 32x plus 60. If I multiply that 5. And then I go to factor this down. So x squared is x times x. 60, I'm looking for what multiplies to 60 and then adds up to a negative 32. And that would be a negative 2 and a negative 30. And finally, to finish it off, I divide by the 5 that I had at the beginning. Okay, so now we can factor that down. So this 2/5 does not reduce, which means the 5 slides back to the front, and that would be a 5x minus 2. And our second piece, 30 divided by 5, does reduce down to 6. So this would be x minus 6. Over, and then one last piece, 10x cubed is just a monomial, so you know that does not reduce. All right, so lots of terms here. We're going to factor everything down. Think of this like we did with number 1 as just one giant. So all of these are in the numerator, all of these are in the denominator. So reducing, we have 2 steps. Step 1, reduce the monomials. So I have 18x squared over 10x cubed. 18 over 10 I can reduce down to 9 over 5. And then x squared, x cubed, I can cancel out an x squared. This leaves us with just an x left behind. And then last step, oh, I have another monomial here, almost missed that. 9x, so 9 over 9, that can also cancel. These x's cannot cancel because they're both in the denominator. You'd have to have one top and one bottom to cancel. All right, so second step to factoring and canceling is to eliminate any common binomials. So this x plus 6 and the 6 plus x are technically the exact same. The x plus 8 has nothing. The 5x minus 2, I can cancel those. And then x minus 6 and 6 minus x, those are the same but opposite, which means, remember, when I eliminate them, it leaves a negative 1 behind. All right, so I think that's everything we can cancel. Take a look through here. Is just x plus 8 times a negative 1, so that'd be a negative x minus 8 over, and then there's an x here, there's a 5x here, so that would be a 5x squared. Okay, on to our second page. This page, we're going to do numbers 8 and 9. So number 8, to represent the perimeter of a rectangle. So perimeter formula is twice the length plus twice the width. right, so let's call this the length, let's call this the width. So we can set up that perimeter formula twice the length. So this I am going to factor out as much as I can. X squared minus 4x. I can take out an x, and that leaves me with x minus 4, over, and then this denominator, I have an x squared. So that's x times x. And multiplying to 4, adding to negative 5 would be minus 4 minus 1. All right, then plus twice the width, twice, and then this is just 6 over x minus 1. There's nothing that factors in that piece. So that's what it looks like initially. Let's start simplifying some things up. So these x minus 4s, I can cancel them because I have the exact same copy top and bottom. So now let's distribute the 2. Think of this as like 2 over 1. So 2 times x over x minus 1 plus, and this one is 2 times 6, which is just 12 over x minus 1. So this is addition. This one, the addition, I can just combine them right up because they have the exact same denominator. Okay, if you don't have the same denominator, you have to do some work to make sure that they do have the same denominator. But these I can just add together, just 2x plus 12 over my common denominator of x minus 1. The denominator, I could take out a GCF, but even if I did, I'd be left with an x plus 6, and that will not cancel with the x minus 1. So I can just leave it in that form. All right, one final example, number 9. Area of a trapezoid. This is a formula that a lot of you guys probably forgot, so I will write it down for you. Area is 1/2 times the sum of the bases multiplied by the height. Okay, so if we're plugging that in, these are the two bases, base 1, base 2, and then this is the height. So let's set everything up. We've got 1/2 times the sum of the bases, so x plus 3 over x plus x plus 9 over 2x, and then multiplied by the height. So 12 over, and that denominator I can factor down. So x squared minus 2x minus 35, I can factor that down to x times x, and multiplying to negative 35, adding to negative 2 would be minus 7 plus 5. All right, so that's where I'm at so far. Next thing I have to do is look inside the parentheses. I have to combine everything up there. They do not have the same denominator like 8 did. So between an x and a 2x, remember we do this back and forth, like what does this one have that this one doesn't? What does that one have that that one doesn't? This denominator and this denominator have an x in common, but this one has a 2 and this one doesn't. So we're gonna multiply top and bottom by 2. Okay, so make sure that gets distributed. So I have 1/2, and then here I can distribute this 2. I have 2x plus 6. And then I can add the x plus 9 all over my common denominator of 2x. And this I have 12 over my factored version here. So I'm just going to keep simplifying. So these, everything combines up to 3x plus 15 over 2x. And then multiplied by 12 over x minus 7, x plus 5. Finally, this 3x plus 15, I can take out a 3 as a GCF, and that leaves me with an x plus 5. So I'm going to rewrite that as 3 times x plus 5, and now I can start eliminating things. So we start by reducing monomials. So the monomials would be 2, 2x, 12. So 2, like this is 2 times 2, which is 4, and I can reduce that with 12. So reduce this by 4, I'm left with 3. Reduce those by 4 and they cancel. This 3 and this 3 would have to multiply because they're in the same half of the fraction, but the x plus 5s could cancel. So numerator, I have a 1, a 3, a 3. That means my numerator would be 9. Denominator, I have an x and an x squared, or I'm sorry, x minus 7. So that ends up with x squared minus 7x.